So I'm at the top of the trail here. It's 1.4 kilometers down to the bottom on a 10 kilometer trail. Even though it's only about 8 or 10 degrees right now, it's 5:30 in the morning. You need to get an early start because by noon it's going to be about 39 or 40 degrees down at the bottom. So let's get going. The geologic processes that created all these rocks are really slow. So it's about 1.5 kilometers down to the bottom, and the rocks down there are about 1.8 billion years old. That means that every millimeter that I descend represents about over 1,000 years of the Earth's geologic history. The process of erosion, on the other hand, is much more rapid. Scientists think it's only about 6 million years that it's taken for the Grand Canyon to have been eroded away. If we do the maths on that, it ends up being about 1/4 of a millimeter of erosion every year, which seems pretty slow, but still much more rapid. And that happens through not just the water itself, but all the sediment it carries with it, the sand and the stones and the silt and the grit. It all slowly wears away like sandpaper down at the rocks at the bottom, creating, over time, this magnificent view. There's not as much erosion happening these days as there used to be, and that's because the Colorado River that runs through the Grand Canyon is dammed at both ends. These dams are used for hydropower and help regulate the flow, but it means that a lot of the sediment that was previously carried downriver is no longer able to be carried down. So that process of erosion is going to be slowed down. Of course, the process of erosion doesn't happen everywhere equally. Where you have hard rock, you get these tall, steep cliffs. And then when you have softer soils, you get these smooth, more horizontal plateaus. Now, it's not a straightforward walk through time. We're not going from, today down to 1.8 billion years ago in a straight line. There are what's called unconformities in the rock.
Unconformities are gaps in time between one rock layer and another. This one here is known as the Great Unconformity. There's a few different reasons why these can form, so I'll link to a video in the description that explains it in more detail.
You sometimes hear geologists talk about the rock layers or stratigraphy of a region as being like pages of a book stacked on top of one another, going back in time. That's really evident here. Alright, here we are, the Colorado River. Now normally the water here would continue down all the way to the Gulf of California, but with the amount of water that's being taken for irrigation, some years it just doesn't even make it all the way down. And tomorrow the hard part begins, the climb back up. So it's nearly 5 in the morning, taking off back up. Been walking for over half an hour and my net elevation gain's been about maybe 20 meters. So I've got like 1,400 to go at least. In case it wasn't clear, I'm filming this on my phone. Ran out of battery on my camera last night. Taking star photos. So, no regrets. Here's a great example of where you can see the water just cutting through solid rock. Carves out these channels, making nice little rock pool homes for tadpoles.
Yeah, I forgot the next couple lines, but then it goes. Secret told secret, 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 secret tunnel.
Alright, and almost exactly 5 hours later, we're at the top. You can certainly feel those 1.8 billion years a bit more this time.